Hi, this is Halal. In this video on mathematical economics series, we will try to solve a problem on Cobb-Douglas production function that was asked by a friend Hinata Chan on Telegram. The question is like this: for Cobb-Douglas production function, Q is equal to A L to the power alpha times K to the power beta. Find out output elasticities with respect to labor and capital. We are being given a typical production function, and we have to find out the output elasticities with respect to labor and capital. Okay, so what is our production function? That is Q is equal to A L to the power alpha K to the power beta. Since nothing is being talked about alpha and beta further, so we can safely assume that alpha plus beta is equal to 1. That means we have a homogeneous Cobb-Douglas production function. Okay, now how do we find out the output elasticities? Output elasticities with respect to labor and capital. What is the formula for finding the output elasticities? So let us denote E L is the output elasticity with respect to L, that is given by the derivative, that is partial derivative of the production function with respect to L and multiplying it with L upon Q. Okay, this is the output elasticity formula. Likewise, we have the price elasticity formula. Same is here. Okay, here we have Q and L. In that case, we have price and quantity in price elasticity of demand. You know that better. Now that means we need to first to take the partial derivative of this Cobb-Douglas production function with respect to L. That means first we need to find out dQ upon dl. Okay, that means partially differentiating this our production function with respect to L. Okay, so what will happen? This alpha will become coefficient, so we have alpha a L to the power alpha minus 1 K to the power beta. How does it happen? If we have to find the derivative of x to the power n, its derivative is simply this n becomes coefficient. Okay, and this n is subtracted by 1. Okay, this is, since we are partially differentiating with respect to L, so here we have L to the power alpha, its derivative is simply alpha will become coefficient, we have L alpha minus 1. Okay, and we have done the partial derivatives assuming a and k is constants here. Okay, so this was about the power function rule. Now we can also rearrange this like this: alpha a L to the power alpha into L to the power minus 1. Okay, we have just expanded this because when bases are same, we can again subtract the powers, and we have k to the power beta, and we can write it like this: alpha a L to the power alpha k to the power beta, and transposing this L to the power minus 1 to denominator, it will become plus 1, so this becomes L. If we have x to the power n, and if we transpose this to denominator, it will become 1 upon x to the power negative n. That means the sign of the exponent changes as we transpose the variable or number to numerator or denominator. Okay, so this was about this law of the exponents. So we got this very thing. Now what will be output elasticity of labor is equal to dq upon dl. We got dq upon dl, this alpha a L to the power alpha k to the power beta upon L into L upon Q. Okay, now here you can easily see, if I just cancel these two, this very thing is equal to Q, which was in question. So I can write EL, that means output elasticity of labor, is equal to alpha. So in place of this very thing, I can write Q upon Q. So Q and Q gets cancelled. We are left with alpha. So output elasticity of labor comes out to be alpha. And what is output elasticity in this case? It simply says how much our output will change if labor changes by 1%. Okay, if labor changes by 1%, how much will our output change? Okay, and this is given by this very number. Okay, so this was about output elasticity of labor, and similarly we can find out the output elasticity with respect to capital. Okay, so let me rub this out. Okay, I will really appreciate if you people please share and subscribe this channel with your econ friends, and if you also want to donate, you can donate via PayPal, and the account is given in the info section of this channel. Okay, so let us see what is output elasticity of capital. Same logic is, so output elasticity of capital is simply given by dq upon dk into k upon q. Okay, that means first we need to differentiate this very function with respect to k. That means dq upon dk, we need to find the derivative with respect to k this time. Okay, so simple, as I have told you, this beta will become this time coefficient. We have a l to the power alpha k to the power, since we are taking the partial derivative with respect to k, so exponent will get subtracted by 1. Okay, now rearranging this, so we have beta a l to the power alpha k to the power beta into k to the power minus 1. Okay, and we can write it like this: beta a to the power alpha, sorry, l to the power alpha k to the power beta, and transposing this to denominator, it will become k to the power plus 1. Okay, that means output elasticity of capital is equal to, now dq upon dk came out to be this: beta a l to the power alpha k to the power beta upon k, and we multiply it by k upon q, k upon q. Okay, here this k and k will get cancelled, and you can visualize again this thing is equal to q, so this comes out to be beta. In place of this we have q upon q, so q and q gets cancelled, we are left with beta. Okay, so this beta tells us, and this beta is our output elasticity with respect to capital. And what is output elasticity with respect to capital? It says us how much, or I will write here, change in output, okay, when there is 1 unit change in what we call it, in capital. I am writing k c a p i t a l. Okay, so output elasticity, yes, output elasticity with respect to capital tells us how much our output will change if there is 1 unit change in capital. Let us say beta is equal to 0.5. What does this tell us? It simply tells us if okay, it simply tells us if beta changes, let us say if beta changes by, if beta changes by 0.5%, I'm not writing it properly, so let me, if beta is equal to 0.5. Okay, what does this tell us? It simply tells us if capital, let us say if capital increases by 1%, okay, output will increase by 0.5% if the value of beta was 5. Similarly, let us say we have output elasticity of labor was, let us say, 0.4. I'm just assuming alpha is 0.4. What does this tell us? It simply tells us if labor increases by 1%, okay, output will increase by 0.4%. Okay, this is about the output elasticity of capital and labor. I hope you people like these videos. Please share and subscribe this channel, and if you want to donate to make it more successful, please you can find the link in the info box also. Thank you.